Hi there, Keys Precalculus. We're going to be going over Chapter 2, Section 3 in 3 parts. This first part is simply a review of polynomial, long division, and synthetic division. We went over it in class, but I'm doing this video just as a refresher for anybody that needs to solidify it in their brains. So the problem that you see up here says find 5x to the third plus 6x plus 8 divided by x plus 2. Remember that fraction part is a divided sign. So we're going to do it first with long division and then with synthetic division. We can do synthetic division on this one because we are dividing by a binomial whose power is 1. But for long division, the first thing we're going to do is set it up. So I'm going to take my divisor and put it on the outside of the dividing bar. And on the inside, I'm going to put 5x to the third. I start with my leading coefficient and I go down in descending order. I go down with powers in descending order. It really is helpful, much less confusing, if you include the placeholders for the powers that do not show up. And because there's not a x to the squared here, I'm going to add in a 0x squared. It's just a placeholder. It doesn't add or subtract anything from the problem. It just holds the x squared place. Plus 6x plus 8. Okay, the first thing I'm going to ask myself is how do I turn this x into the leading term, 5x to the third? Well, I would have to multiply it by 5x squared. So I'm going to put that above my x squared place. I want to keep everything lined up. If this helps to turn your paper sideways and use columns, go ahead and do that. Okay, 5x, and then what I'm going to do after I figure out how to turn x into 5x to the third, I'm going to take this 5x squared and I'm going to multiply it by every term of my divisor. So 5x squared times x gives me 5x to the third. And then 5x squared times 2 gives me 10x squared. Now, just like in regular dividing, I'm going to subtract. But to subtracting polynomials, it's really distributing a -1 to each part, so I'm just going to change the sign of all the terms. And then add down. So 5x to the third plus -5x to the third is 0. 0 plus a -10x to the third or minus 10x to the third is 10x squared. And then I'm going to bring down the next term, plus 6x. Now I want to see how x can become the leading term of what I just subtracted, -10x squared. I would have to multiply it by -10x in order to turn it into -10x squared, so I'm going to write that up here. And then I take this -10x and I multiply every term in my divisor by that number. -10x times x gives me -10x squared, and then -10x times 2 gives me -20x. I am now going to subtract, and in order to subtract, that means I change every sign, so this becomes a positive and that becomes a positive. So when I subtract these, the x squared term goes away and 6x, or actually I'm adding them now since I changed the sign. The x squared term goes away and 6x plus 20x gives me 26x, and now I'm bringing down my 8 plus 8. Now I have to decide how can I turn x into 26x, this x here into this one right here, into 26x. Well, I multiply it by 26. And then I have to multiply every term in my divisor. So 26 times x gives me 26x, and 26 times 2 gives me 52. I'm going to change my signs so I can add instead of subtracting. That becomes nothing, and this becomes -44. So I take that remainder and I add it, but because it's -44, I can subtract it. I can see if I can erase this. Hold on. Erase that and make it minus 44 over my divisor, x plus 2. So by long division, this equals, in other words, 5x to the third plus 6x plus 8 divided by x plus 2 is equal to 5x squared minus 10x plus 26 plus the remainder, negative 44, over x plus 2. Or I could have said minus 44 over x plus 2. Either one of these is correct. I can write it this way. In fact, this is how you should write your answer. This is the function divided by the divisor. That's this blue function over here divided by the yellow divisor is equal to the quotient. The quotient is the answer to a division problem, which is what I highlighted here in pink, plus the remainder, which is highlighted in green, divided by the divisor. That's how you should write your answer. And what I tried to do is I highlighted everything in the problem to the color of what it is up here in the formula. Okay, so go ahead and pause the video for a second and study and see what I've done. Another way of looking at this is you can say that your function is equivalent to the divisor, which is x plus 2, times the quotient, which is what we found. It's the answer to a division problem. 5x to the second, 5x squared minus 10x plus 26. Those two numbers multiplied together will give me almost the 5x to the third plus 6x plus 8. But before it does that, I have to add what was left over, the remainder, which is negative 44. So I could say minus 44. Like I said earlier, I could have written this as x plus 2 times 5x squared minus 10x plus 26 minus 44. And if you were to multiply this out and then subtract 44 from it, you would end up with 5x to the third plus 6x plus 8. This blue, this blue polynomial over here. Here, I went ahead and highlighted all the colors. So again, take a moment, pause the video, look at the colors, compare what you see. I'm hoping this makes sense. I'm hoping the division algorithm makes sense. I'm pretty sure y'all understand how to do long division with your polynomials, but I want you to see how the division algorithm works. Like I said, go ahead and study it for a minute or two because I'm going to erase most of this to do synthetic division. Now we're going to solve this same problem, 5x to the third plus 6x plus 8 divided by x plus 2 using synthetic division. The problem here, and I highlighted the dividend and the divisor. The dividend, remember, we made it in blue, and the divisor, that's my f of x, my divisor, which is d of x, I highlighted in yellow. And then I'm going to draw my synthetic division box here, and I like to put a line here to separate what my remainder is from the rest of it. And what I'm going to put right here is the opposite of 2. If x minus 2 is a factor, then negative 2 would be a 0. We know it's not a 0 because we've already divided it with long division. But if it was, then it would x minus 2 would be a 0. Or excuse me, negative 2 would be a 0 if x plus 2 is a factor. But the other reason why we changed the sign is that way when we do our synthetic division, we can add instead of subtract. It makes things a lot simpler to work. Okay, so now what I'm going to do is I'm going to write down the coefficients of my dividend. They're 5, 6, and 8. However, I have to have every exponent represented. And since I start with x to the third, I'm going to have to also have an x squared, an x to the 1, and an x to the 0. There is not an x squared here, so I need to put a placeholder. So I'm going to put a 5. I'm going to put a 0 for the x squared term. I'm going to put a 6 for the x term, and I'm going to put an 8 for the constant. I also took a moment to highlight these terms so you can see that the blue ones, the coefficient, are the coefficients of the dividend, and the yellow is the opposite of the divisor, the opposite constant of the divisor. Okay, now I'm going to also try to use the same color that I use in long division to show you how it matches up. So the first thing we're going to do with synthetic division is we're going to drop down this first number, the leading coefficient. That just drops down to a 5. And do you see how I wrote it in blue, just like over here on my long division, my leading coefficient, my quotient, is also a 5. Now, I'm going to multiply -2 times 5 to get a -10. Hang on. So I'll put that answer up here, -10. This number is, I don't know if you can see where I'm circling, came from this number that well, I'll draw an arrow to it. This -10 right here. That's why I kept it in blue. Now I'm going to change the color because now I add straight down 0. So I'm back to my synthetic division. 0 minus 10, or 0 plus a -10 is -10. And I made it this purplish color so you can see that it matches this -10 over here in my long division, the coefficient of x. And then I'm going to I'm going to multiply -2 times -10 to get 20. And I want you to see where that came from. That came from right here. That came right here. Actually, that other -10 did not come from the one I put the arrow to. I apologize. It came from this -10 right here that I'm circling. That's the same. So this light blue -10 on my synthetic division is the same -10 that I just circled on the long division. And the 20 up here on my synthetic division is the same as this 20 I circled on my long division. But when I add 6 and 20, I get 26, which I put in green because that's the number that I have up here in my long division in green. Okay, now -2 times 26, so I'm coming back to synthetic division, and I'm multiplying -2, this yellow, times the green 26 to get -52. This is the same number that I'm circling here in my long division problem. Okay, now I'm going to add, just like I do here, 8 plus a -52 is -44. Well, 8 here in my synthetic division plus a -52 is in fact -44. So now what I'm going to do is I'm going to say, what's my answer? How many times does x plus 2 go into 5x to the third plus 6x plus 8? Well, what I'm going to do is I'm going to rewrite this. These are my new coefficients. And because I'm dividing by a binomial with the power of 1, I'm going to go 1 degree down from my dividend degree. Okay, that 3 that I'm x to the third. So it's going to be x squared. So my 5 becomes the new coefficient, new leading coefficient, 5x squared. My 10 becomes minus 10x. And my 26 is my constant. That's my quotient. Plus I have a remainder. And my remainder is -44 over my divisor, x plus 2. I'm going to go ahead and highlight these so you can see where they match. By synthetic division, I found that 5x to the third plus 6x plus 8 divided by x plus 2 is equal to 5x squared minus 10x plus 26 minus 44 over x plus 2, or plus a -44 over x plus 2. I get the same answer when I do both problems. Okay, just take a moment, study it, see how everything matches, and then go ahead and go and practice your polynomial long division and synthetic division for your homework. I'll see you in a bit for part 2 of this section.